Okay, so we've talked about polar bonds and nonpolar bonds and how those depend on the electronegativity difference between the two atoms that are bonded together. We also need to think about the polarity of an entire molecule. So if we have a very simple molecule of two atoms, such as this one, then the polarity of the molecule will depend on the polarity of the bond, because there is only one bond. If that bond is polar, then the whole molecule is polar. So here we have hydrogen and chlorine, two different nonmetals, and according to my shortcut rules, I expect you to tell me that that's a polar bond, because they're different nonmetals. So we have a net dipole moment, meaning there's a separation of charge on this molecule. So we indicate that with this arrow pointing towards the more negative end of the bond, with a little plus over here towards the positive. Here's an illustration of electron density around this molecule. So here's the chlorine and the hydrogen, and there's more electron density around the chlorine. The chlorine is more electronegative, it's more attractive to the electrons, and so it pulls the electrons towards itself and away from the hydrogen. So the hydrogen end has a partial positive charge, the chlorine has a partial negative charge. In a polyatomic molecule, things get a little more complicated because the polarity of the molecule depends on the geometry. And so we're going to look at that. If the dipole moments of the individual polar bonds cancel out, then the molecule can be nonpolar. So you can have polar bonds in a nonpolar molecule. Let's look at carbon dioxide. Carbon dioxide has two carbon-oxygen double bonds, and both of those bonds are polar. So here we have an illustration of that. Here's this dipole moment and this dipole moment going in the opposite direction. We can think of the oxygens as pulling electron density away from the carbon, and they're both pulling electron density away from the carbon. So both ends of the molecule would be slightly negative compared to the middle of the molecule, but we don't have one end of the molecule being different from the other end of the molecule, right? And so this is not going to act like a magnet where one end is positive and one end is negative, one's north and south. So